Hello, and welcome to the Health Data Ethics Podcast. I'm your host, Jenny Owens, and in this episode, we're going to talk about GPTs. We're going to talk about how they work. We're going to dive in a little bit into some of the underlying science and math behind a GPT so that we in healthcare can understand better how GPTs work and therefore what they're good at and what they're not good at. And I have to tell you that this whole conversation got kicked off when my husband cheated on the NYTimes Games. He went and added the suggestions for strands. We've been playing our NYTimes Games every day. We always send each other our scores, and he couldn't come up with a theme for strands, and he was trying to get ChatGPT to generate for him a bunch of words in a specific category that all contained the letter W. And ChatGPT went wildly off the rails, gave him a list of things that did not contain the letter W, and he tried to course correct and said, no, this is not accurate. Can you please give me a list of words that contain the letter W? And ChatGPT doubled down and then tripled down. And I thought this was really interesting because it really accords with my understanding of how GPTs work. And then I thought, well, now wait a minute, let's dive into this because it's really important to understand what LLMs and GPTs can do well and what they are giving the impression of doing that they're not actually doing. So this is going to be a big episode. It's going to be perhaps a little bit longer of an episode. We have lots to cover. Let's get started. So we're going to talk briefly about GPTs. So GPT is Generative Pre-trained Transformer, and it's the transformer there that is really the critical thing. A transformer is a neural net that can apply a specific code or a specific action to a block of text. So we're going to dig into what the various levels of transformers are doing as a GPT is calculating through the prompt that you've given it and searching for its response. The best way to think about this, and bear with me because this is a little bit of a high level concept, is that when you give a prompt to a GPT, you're giving it a text prompt. Text is made up of words. And from the perspective of a GPT, those words exist in a multi-dimensional vector space, not an intuitive concept. So let's think about three-dimensional geography. If you think about three-dimensional geography, it is very easy to pinpoint a location based on its latitude, its longitude, and its elevation above sea level. So if you give me three vectors, boom, 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 we might be able to find one of my favorite places in the world, the Monterey Bay Aquarium. And as you're looking around, if you were to adjust this latitude, longitude, and elevation a little bit, you might find some things which are geographically associated with the Monterey Bay Aquarium. Like you might find otters outside of the aquarium. You might find a parking lot near the aquarium. You might find kelp and the Monterey Bay itself all in the same geographical region because these vectors tell you about how these locations are related to each other geographically. Similarly, if you think about a multi-dimensional word vector space, you're going to get vectors that are going to tell you how words are related to each other in terms of their meaning and their relationships to each other. So words like otter might be associated with words like cute and categories like mammal and environmental words like kelp. And those would all occupy a similar space in that word vector space. This is helpful because a GPT, just like any other computer function, is about math, right? So although you cannot do math on words unless you're doing the old school sideways arithmetic from Wayside School type stuff, you can in fact do math on vectors. So if you take our Monterey Bay Aquarium, transform it into some vectors, then you can do math on the vectors and actually transform that into the Baltimore Aquarium. Same thing, different coast, still pretty cool. So the vector word space is a way of assigning words a mathematical sort of geography about their meaning and their context and their relationship to each other. And it's not perfect, which is where things get interesting. GPTs rely on transformers, right? That's the T in GPT, to encode a few different things. The first thing you do when you give a blob of text to a GPT is that it uses a transformer to encode the context and the text input. So if I were to give a GPT the sentence, Jenny loves to see, or I guess the sentence fragment, Jenny loves to see her favorite animals at the, we might apply multiple levels of transformer to that, right? We might apply a transformer that's going to identify the part of speech, each word in that sentence fragment. We might apply a transformer that is going to look for her is a pronoun. Which noun in this sentence fragment is that likely to refer to? We might apply a transformer that's going to look at some sentiment analysis. So we've got loves and favorite. That's some positive sentiments. We're going to be looking for things that tend to be associated with positive feelings. So the first transformer is going to be encoding some context and taking that prompt and kind of breaking it down into a mapped sentence fragment in a way that the GPT can then work on. The next steps are where your training comes into play. So GPTs get trained on all manner of things, including specialized text for specialized contexts. So for example, we've got large language models that are trained specifically for the medical context. They're also often trained using text that's harvested from the internet, open source literature. There's a lot of really interesting things that we can dive into here. But I just wanted to make sure that you're aware that the large language models are trained only on text. They are trained on words, and they do not understand the meaning that is carried by those words, right? They're looking at these words, again, like they're a map in vector space. It's the difference between looking at a map of California and actually driving to the Monterey Bay Aquarium. Very different. Your GPT only has a map. It can pinpoint things on the map and say how they are related to each other. Excuse me. So after we've got our initial text prompt encoded, the next thing we want to do is we want to link it up and understand the associations between those individual chunks of text. So we're gonna apply some additional transformers to that. That's going to be able to connect, for example, pronouns with the noun that they're most likely to go with. We're going to be looking to hook up verbs with their subjects and make sure that we're understanding. And I use the word understanding incorrectly here, right? A GPT does not understand that verbs tend to have objects, right? A GPT understands that, verbs are mathematically associated probabilistically with these other kinds of words. That's all it's doing. It's just following the probabilities. So first we encode, and then we're going to apply more transformers. We're going to connect this text blob together in a way that makes the GPT then able to calculate what is most likely to come next. And that's when you start to get the generative portion of your answer, right? So it's the calculation portion where the largest number of transformer layers happen to come in. You get lots of layers, lots of neurons that are coming in into this, and there's tons of vector math involved. But crucially, if you make an error early on, either in the encoding or in the connecting or in the early levels of the prediction, it's very difficult to backtrack. People tend to be pretty good about this, right? We're good at course correcting. We're good at starting a sentence and saying, wait a minute, I didn't mean for it to go that way. Let me back up and rephrase. GPTs do not really have this capability. And so, to return to my cheating husband, gotta be careful what I say here. Let me back up. To return to my husband cheating on his NYTimes Games, once the GPT had decided that the word cinnamon, for example, contained the letter W, it was very sure about that. And it assured him many times that the word cinnamon contained the letter W. So all of these transformer layers get trained on various blobs of text. What's really interesting to me is what's not here, right? This whole structure hinges on mathematically understanding what words tend to occur close to each other in text that is available for training. That's it. A GPT does not have an underlying worldview. It does not have an understanding of basic physics. It doesn't have common sense. It doesn't have, it's good at encoding text, but it does not extract meaning from it. This is just a mathematical operation that happens to put out words at the end instead of numbers. So it's really interesting because there's also not a good narrative, right? I don't know if you've ever tried to read AI generated stories, but they really struggle with things like story beats and irony. It also really struggles with memory windows. So although I may be able to take a look at an email and remember and place it in context of my relationship with this person, what I know is going on in their work life outside of the context of the email, a GPT does not have that, right? If I throw just the text of the email in, it's going to give me back a summary that is predicated only on what I fed it. So GPTs, they do some things very well. They do other things not so well. I frequently mention that good use cases for artificial intelligence in healthcare are things that people don't do particularly well, but that AI does do really well. Things that GPTs are really good at: summarizing text, taking large blocks of text and deciding what is most likely to be relevant if they've been appropriately trained. What people are good at, that the LLMs aren't always, is tailoring. Making sure that tone fits, making sure that the required information is there for effective communication. I don't know if you've ever had the experience of trying to get ChatGPT to generate something for you, and it just kind of keeps missing the mark in a way that's difficult to put your finger on, but you know it's not quite what you want. So I think this is interesting for a number of reasons. One is that when you're thinking about implementing artificial intelligence in the healthcare space, you have to remember that correcting is difficult for large language models and requires really human supervision and human intervention. So if you end up with hallucinations, if you end up with text that veers off wildly from what you expected, this is actually a sign that the GPT is functioning as intended. But then you have to also intend to do the correction and to have a backup plan in the event that the text that's generated is not fit for purpose. Last but not least, the thing that I cannot emphasize enough is that large language models and GPT output, it does not reflect an underlying understanding of the words. These are words that are statistically likely to follow each other. It is a souped up version of the autocorrect on your phone, as my friend would say. And so I think it's really important to always be engaging really critically with the output of a GPT to make sure that it is in fact saying what you want it to say. If you have questions, if you have concerns, if you have a different experience with your GPT, if I've gotten some technical details wrong, and I am quite sure that there are many, many levels that we could dive in deeper on the details, drop me a comment below. I would love to hear more about it.